Welcome to this Trimble Business Center tutorial demonstration video on the new Create Tunnel Inspection Map command in Trimble Business Center Tunneling Module version 5.4. The tunnel inspection map is used to compare two sets of data for quality control analysis, such as in excavation, shotcrete, or lining control applications. The tunnel inspection map is a 3D mesh object that allows you to visualize the deviations between those two tunnel meshes. The meshes that can be compared with this feature are design to as-built or as-built to as-built mesh comparison. Once created, you can view those deviations using a 3D color mapping of the inspection map, and you can also customize that color map based on your project requirements. This is the first step in the 4-step process of the tunnel inspection workflow. To start, in this project, I already have some total station data that was collected. You can see here that was measured with the green vector lines, and it's created the resulting as-built meshes, which are shown in cyan, and the design mesh, which is shown in red. Now I'll turn off some of this data to make it easier to see. So we only have the meshes currently. So to perform an inspection on the tunnel, first we start by creating the inspection map. You can find that here under the TBC Tunnels ribbon. We start by giving the inspection a name. In this case, I am assessing the excavation layer versus the design. So I'll type in excavation inspection, and I can give it a classification. So this tells me what I'm comparing to. In this case, I'm going to do design versus excavation. I can also put it on a layer if I want. For instance, I can put it on a new layer, and I can call this layer inspection. Following that, now I can choose which meshes I'm going to compare. To start, the base mesh is what will be compared to. So typically this will be the design mesh, but it could also be an as-built versus as-built. For instance, if you're comparing shotcrete to excavation, you want the excavation to be the design base mesh. In this case, I have a design mesh, and I'll use that. And I'll compare it to the as-built mesh. So that is the red mesh versus this blue mesh. And then I can choose a range of stations which I want to apply this on. So if I only wanted a section of this to be calculated, for instance, if I choose from the start of the tunnel here to this section here, I can choose that. I can also do the whole length. Once I've done that, I press OK, and this will generate the inspection mesh. Once the inspection mesh has been created, you'll see it shown in the plan and 3D views. I'll turn off the other meshes to show what this looks like. So the corresponding shape of the inspection mesh is defined by the base mesh. So in our case, it was the design mesh. And then it is colored corresponding to the deviations between the two compared meshes. So I can see different colors along this mesh in the gridded layout. So any areas that aren't green are areas that are further away from the two meshes. Anywhere that is green is closer to the two meshes being 0. Now, one way to further analyze this mesh is we can view the properties. Under the properties tab, we see the name, the classification, which we can change, and some other statistics regarding that mesh, such as the areas and the volumes for over and under break, as well as the tolerance. I can change the over and under break. For instance, if I want to put 0.2 as the over break and negative 0.2 as the under break, this will change those values accordingly for the areas and volumes. The delta tolerance is to set any deviations that are higher than this tolerance won't be computed. For instance, if you have some data that's very far away from the mesh, that might be a bad point measurement or some other data that you don't want to analyze, you can set this tolerance and nothing outside of that delta will be calculated. For instance, we can see here that data where the cross passage met isn't calculated as a part of this mesh because the delta tolerance is set to 1. I can change this though. So for instance, if I want to get any deltas that were up to 2 meters away, I can do that. There's also an option to remove intersecting lines, and this is in cases where there's sharp corners compared between the two meshes where the the design versus the as-built might overlap, and we only want to show one deviation. I suggest leaving this to yes in most circumstances. You can also change any of the way that this shape is viewed in the 3D and time views.